guys know I play that every time? I guess got a little fiddle here that I make this rock and roll. Welcome, rock stars, to another video, and this video is about percents. But I just got something I got to ask you. Super important question. What do you call a train carrying gum? It's a choo-choo train. He chews on the gum. Choo-choo train. Chews on the gum. Choo-choo train. Yeah, these little ditties have lyrics. I don't think you knew that. So the goal today is for you to be able to estimate and determine a percent. And so how are you going to estimate and determine a percent? You are going to look at, sometimes you're going to be looking at pictures. Sometimes it's going to be on a number line. Sometimes it'll be a verbal description. A verbal description simply means someone is like it's written out, or it's like a real world, like, you know, a word problem. And these are going to include percents that are greater than 100% and even less than 1%. We're going to get into that. But guess what comes next? It's vocabulary time. Welcome, boys and girls, to vocabulary. Okay, so percents. What are percents? Percents simply are parts per hundred. So it's something out of 100 will give you a percent. Okay, so if you ever have seen someone get a paper graded and there was 100 questions on the test and they got 77 of those questions correct, guess what their percent would be? 77 out of 100. And if you think about a classroom that you're sitting in right now, or maybe you're looking out into the mall and you see a bunch of people walking around the mall, and your answer is like, well, I only have 13 out of 48 people that are wearing hats. It's not 13% because it's not out of 100, but we're going to show you how to figure out that percent. So in other words, anything over 100, that number on top is going to be the percent. So go ahead and look at the next one. This one's estimate or estimate. So this is when you're doing stuff in math and you're like trying to figure out, or just in the world, where you're just trying to figure out like the approximate or like close to the actual value by doing a little bit of like smaller calculations, but not getting down to the most accurate answer. I want you to think about eating an apple, and if you were eating it and you took like 4 or 5 bites, you would look down and I would say like about what percentage of that apple have you eaten, or how much of that apple have you eaten? You might say, well, it's not exactly a half, but it's real close to a half. An estimate is finding as close enough to the right answer as possible without going into the complete detail. Okay, so let's work. Let's talk about percent. Again, I told you that percent means per 100. And another way to phrase that is how many out of 100. 7 out of 100 kids were wearing a hat to school one day. 13 out of 100 kids love 99 out of 100 kids love my dad jokes. And so 99 out of 100 would be 99% of kids love my math jokes. And you guys, that's just math. You can't argue with it. It's good stuff. It's just good jokes. All right, so that's what that means. But the other thing we really need to understand is all fractions and decimals can also be written as percents. And like, if you could get this through right now where you understand that fractions and decimals and percents all represent the same thing. They're just different ways. Some people like to have their answers in percent. Sometimes they need a fraction. Sometimes they need a decimal. But they all represent the same thing. Okay, do you guys remember this thing? Have you ever seen it? Think back to your early elementary school days. This is a plate or a grid, and there are 10 squares going this way, and there are 10 squares going this way. So if I have 10 rows of 10, that means that this thing represents 100 squares. I just need to make sure you understand that, because we're going to go to the next one and say, now we have a grid that's partially filled out. And we just talked about that it's 10, and another 10, and another 10, and another 10. So that's 4 10s, right? 10, 20, 30, 40. And then we have 1, 2, 3, 4, 5, 6. So I have 46 of these shaded in. Out of how many? Man, did you say something about out of 100 means something? Well, this grid is out of 100. It's 46 out of 100. So what is this grid? What percent of this grid is filled out? Boom! 46%. As long as it's out of 100. That's really, really important. I'm not going to keep circling it. Keep circling it. Keep circling it. As long as it's out of 100, that would be your percent that's on top. Okay? Now, when we think about percents, we really want to make sure we understand like their benchmark percents. So if you're not understanding what benchmarks are yet, just think of a fraction. A half is a benchmark fraction, because that's just something that all of us can relate to. We can think of an apple and think about, what does a half of it look like? So that would be a benchmark fraction. So when you're estimating, you could say, oh, it's close to a half. And sometimes you're saying that just because if I can say something's close to a half and another thing's close to a whole, I don't have to do all this crazy calculations. I can just say, well, the one that's close to a whole is bigger than the one that's closer to a half. And that's why we use benchmark fractions. Well, now we're going to talk about benchmark percents. So let's look at the most basic benchmark percent, okay? And that would be this one, 0%. What is 0%? That's none. That means out of 100, nothing. The next one is the second easiest one, which means out of the classroom. How many of the people in the classroom are humans? Well, you can say all of them. So 100% of my classroom is humans. Now I would kind of argue with that a little bit, but that's okay. For this sake, let's just act like you guys all are humans. Next up, we'd say 50. 50% is a benchmark fraction. We already talked about it. It's about half of the material, half of the collection. Okay. Then we have 25%. So if we had a group of people, or just a collection of whatever we want to call it. So we have this thing where we have a collection of all these things in here, and we say, let's split it in half. So that's half, and that's half. Just imagine that each side of those is the same amount of data. Well, a quarter, or 25%, would be half of each of those halves. This little collection would be 25%. This little collection would be 25%. This little collection would be 25%. And this collection would be 25%, okay? So they're 1/4. There's 4 sections that are 25, and another 25 gives me 50, and another 25 gives me 75, and another 25 gives me 100. So 25% would be about 1/4 of the data. It's easy to kind of picture a pizza, right? We just kind of say, here's a pizza, here's half of it, and here would be 1/4 of it, right? So along those same lines, I'm going to keep my pizza drawn right there and say, oh, 75%. Well, this was 25%, this was half of the pizza, and this is 75%. So you take your group and you break it into 4 parts and you say about 3 of them exactly would be 75%. So when we're estimating, we look around the room and say, how many people are wearing hats? You look around and be like, well, not all of them, and it's more than half. It looks like it's pretty close to 75%. These are benchmark percents that we want to make sure we understand. Okay, and there's 2 more that you're going to get into a little later, and I'll just go ahead and give you a quick intro to them. One of them goes about right there, and he's 33%. And his cousin goes right over here, and he's about 66%. Okay, 66% and 33%, those are thirds. So you look around the room and you're like, it's not a half, it's bigger than a quarter, so it's probably a third, like 33%. But what happens if we get data and it's not out of 100? Well, let's get to 100! All right, so what is this out of? So we have 10. And how many of them are filled in? 1, 2, 3, 4. So we have 4 out of 10. So 4%. Wrong. It's not 4%. Because it has to be out of 100 to get the percent. So now we're going to get into that whole thing about equivalent fractions. All right, so we're going to take this fraction and we're going to turn it into 100. We can't just do that. There has to be for it to be equivalent, whatever we do to the bottom, we have to do to the top so that they're making an equal jump on both of them. So it's always going to be multiplication or division. So what did I do to get from the 10 to the 100? I got bigger, so it's automatically multiplication. And what did I multiply that 10 by to get to the 100? I multiplied it by 10, because 10 times 10 is 100. So let's do the same thing over here. If I multiplied by 10 on the bottom, I have to multiply by 10 on the top. And so 4 times 10 is what? It is 40. I have 40 out of 100. I remember you saying 40, anything out of 100 is a percent. 40 out of 100 is 40%. Boom. There's your answer. Get to 100. Let's do a couple more get to 100s, all right? Let's take this first one and say, let's get to 100. What did I do to 150 to get to 100? I got bigger, so I multiplied. 50 times what equals 100? Well, 2 50s equals 100, so I doubled it, which means I double the top. 4 out of 100. What percent? 4%. Let's go here. Let's get to 100. What did I do from 25 to get to 100? 25, 50, 75, 100. 4 times bigger. So I multiplied by 4, which means I have to multiply by 4. What's 6 times 4? That would be 24. 24%. See what I mean? When you get to 100, life is pretty easy. So this one, let's get to 100. 4 groups of what gets me to 100? Well, you could count by 4s, or you could kind of look back at that last question and say, oh, 25 groups of 4 is 100, so 4 groups of 25 must equal 100, right? So then we multiply the top by 25. We say 25, 50, right? So we have 5 groups of 25. So 25, 50, 75, 100, and one more 25 gives us 125. Wait a second. That number on top is bigger than 100. Well, that means it's 125%. So this one is more than a whole. 125% of something took place. Okay? All right. So let's look at this one, speaking of bigger than a whole. Because now I can look at this right off the bat and say, I already see a whole and a whole. I already have 2 wholes. And then I have this thing down here, which is 3 out of 4. But how many fourths do I have in all? Well, I have 4 fourths, and I have another 4 fourths. So that's 8 fourths. 4 plus 4 is 8. And then I have 9, 10, 11. So I have 11 fourths. I'm trying to figure out a percent, y'all. What do we do? Is there 100 on the bottom? No. Let's get to 100. Let's go up here and we turn this 4 into 100. We got 4 to 100, which means we got bigger. Which we multiplied. We just did this type of problem already. 4 groups of what gives you 100? Think of 100 as pennies. Or think of 100 as a dollar. And a dollar, when we break it into 4 pieces, what do we have? We have those big old quarters, right? 4 groups of 25. A quarter is 25. So that means we multiply the top by 25. And we got that our answer is 275 out of 100. So the percent is out of 100. And we know it is actually 275%. Da-da-da-da-da. We just did it. Okay. Now let's look at it in a word. Remember I told you it might be in a real world situation, a word problem, if you will. So Jamie and his friends were eating candy after lunch. Classic kids. And I bet if I really looked into it, they were eating the candy before the lunch. Anyway, they had this big old bag of candy. And in that bag of candy, there were 50 pieces. And when they got done eating, they ate all but 7. What kind of candy eating session are we talking about here? Anyway, so at the end of it, there was 7 pieces left. So the bag only had 7 left. What percent of the candy did the group eat? Well, how much of the candy did they eat? If they had 50, there's only 7 left. Well, let's go ahead and say, what's 50 minus 7? And that will give us 43. So there's 43 pieces of that candy left. And it's 43 what? It's 43. I'm going to go ahead and remember that number. 43. I'm going to erase the screen. 43. All right. It was 43 pieces of candy out of what? Out of 50. We need a percent. We got to get this out of 100. All right. So what did I do to get to the 50 to the 100? I doubled it. So that means I got to double the top up here. What's 43 doubled? What's 43 times 2? 43 times 2. 2 times 3 is 6. 4 times 2 is 8. 86. These guys ate 86% of the candy, and I didn't get any of it. That's just classic kids these days. Classic kids these days. Look at the problems. Break down what they're asking. Set it up so that if it's asking for a percent, that you can get yourself to eventually get to 100. And once you get to 100, life is good. Hey, it's wrap-up time. Let's wrap up this percentage thing. Why did it get hot in the ballpark after the game? So why did it get hot at the baseball stadium after the game? Should be hot during the game. Oh, I know why. Because all the fans left. The fans are leaving? No, the fans of the game are leaving, but the fans keep you. That's a good joke. I didn't hear anyone laugh. But thanks for watching. See ya!